Okay, guys, I just felt like I needed to get with you about Chapter 11 review. I'm seeing a lot of kind of misconceptions and questions that haven't been answered, so I wanted to go over a few things from the review guide with you and show you a few things as well. One of the main things that I'm seeing is on question number 3, what type of bonds hold the bases together? I think you guys are thinking they're nitrogen bases, so it's nitrogen bonds. It's not. It should be hydrogen bonds. And that is something, if you remember, we talked about in chapter 6. And what's important about that is they're a weaker bond. And since they're weak, that's less energy that has to be used by the cell to break those bonds every time replication has to occur. So that's one that I definitely wanted to go over with you guys. That was number 3. Something else that I wanted to talk to you guys about is just kind of going through the different types of processes that are involved with chapter 11. The first one is replication. And with replication, what I want you guys to remember is you're taking DNA and you're making DNA. Okay? And this is pretty simple, and this I think most of you guys have gotten, but if you've got the following strand, then if you've got this strand and you want to make a complementary strand, like what the cell would do in the nucleus when replication takes place, you're just pairing your A's with your T's and your G's with your C's, like that. So that will be replication. Another process that we've talked about is how the cell then would take DNA and make RNA. And this is called transcription. And once again, this is going to take place in the nucleus as well. So this is going from DNA to RNA. And so what that would look like, I'm going to kind of draw that strand again, and I'm just making this up. It could be anything that, any number of combinations. But the RNA strand, and really guys, this is messenger RNA. I mean, that's not really important for this quiz, but just so that you know, maybe for some of your upper level classes, that's what we're making here. So how would we do that? So you still have your T's are still going to be paired with your A's, C's with G's, but instead of putting a T here like we would when we're doing replication, this is now going to be a U. So we're going to carry this on out, and that should be your transcribed strand. Okay, guys, so now what we would do is we're going to talk about translation. Now, another word for translation is protein synthesis, because we're making a protein. So if you hear that term, just know that it's the same as translation. So in translation, we're taking RNA that we've made from the DNA, and we're going to use that to make the protein. Now, something to keep in mind is replication and transcription have taken place in the nucleus. Translation is going to take place at the ribosome. Okay, so what we're going to do now is we're going to have to, if we're going to have a strand here, and I'm just going to take this strand that we just made up here, and I'm going to add some things to it. And we're going to have to use this chart to do that. And some of you, I think, left this blank, so I wanted to make sure everybody understood how to do it. So basically what we do is we break this into threes, because if you notice, all these codes in the chart here are in threes. And then we just look them up on the chart, and it's going to tell us what this particular codon codes for in amino acid language. So AGU, when we look up here, here's AGU, and there it is. It's serine, and you guys can see that right here on the chart. Then ACC, we've got ACC, and that's going to be threonine, so we're just going to abbreviate that THR. And then UGC, when we look up here, is going to be cysteine. There we go. And that's all you have to do for that. Now, I will say, if you have a quiz on your quiz or your test. And if this strand has T's in it instead of U's, then you're going to have to do transcription first. And because you have to have it in the RNA language before you can read the chart. So if that happens, all you have to do is just take the strand, change it into the RNA language here through your transcription, and then you can read the chart. Something else I wanted to go over with you guys really quickly is a lot of you had left off you had the types of RNA, but their functions, really important. Messenger RNA, really, that's what this is. We said it's going to carry that code out of the nucleus to the ribosome. Also, transfer RNA, it's going to actually take the amino acid. So it's going to take these portions right here that have been made using this codon, and it's actually going to take that to the ribosome where ribosomal RNA is, which is ribosomal's job is to put it all together. So ribosomal kind of puts the protein together, it makes up the protein. Transfer is going to bring the amino acids, and messenger is going to bring the code. So I think that will clear up a few things for you. Also, one other thing I wanted to talk about is mutations. The main cause of mutations are going to be chemicals and radiation. And that can be broken down into a whole lot of other things, because you could talk about X-rays and UV rays and all kinds of radiation. But basically, chemicals and radiation covers most of the sources of mutations. Also, something else I want to talk to you guys about is differences in the different types. Like if you had the following, and I'm just making this real simple, CCC, and if there was a mutation that changed that to a G, then that will be a point mutation, because all you're doing is substituting one base for another. Now, would that cause a change in the protein? It depends. If you look up in the chart, you can see that CCC codes for proline. But what about GCC? GCC codes for alanine, so that would cause a change. However, if you look up here, if CCC had been changed to CCU, both of those still code for proline, so that wouldn't be a change. That will be a silent mutation. It's still a change, but it doesn't cause a different protein to be coded for. Also, if we took this, and let's say that we just got rid of that C altogether, we deleted it. A deletion is going to be a point mutation, a frame shift mutation. Another thing that will be frame shift, if we added some bases, that will be a frame shift mutation as well, because it's going to shift how we read this codon chart. And so definitely if you have a frame shift mutation, you're going to have a change in the protein. I hope this is helpful. If you have any questions, feel free to email me, and good luck on the quiz tomorrow.